Rajkumar is one of my PC scholar. He is working in robot-assisted image processing. Okay, so followed by another scholar, that is Deep Patel, and he is working with IoT, integration of IoT using in manufacturing. That is based on all the CNC machines, robots, etc. So there is a mix of. So this today's session is a mix of all V3. Okay, so now I kindly request the Rajkumar to proceed with the presentation.
Good afternoon, all. Okay, is my screen visible?
Okay, visible, but you can also show your face and for a while, and
you can also my camera in now. So I will come after some time. So I will share my screen now. So shall I start, sir?
You can unmute your video. Unmute your video for a while. Okay, then so that others also could see your face and.
Sir, I don't have the camera right now. Okay, I will have an.
Then okay, no, it is better, right? You don't have, okay.
Fine, sir.
Okay, the system is not attached.
Yes,
okay,
sir. Not
okay. The later maybe we can later you can come to my cabinet. Okay.
Fine.
Yeah.
Yeah.
Okay. Yes.
Okay, fine. So now this part 2 session is about integrating vision system and robot manipulator in IoT-enabled digital reconstruction systems. So here we are going to take some case study kind of thing to understand more about IoT integration with vision system and robot manipulator. So there are much more types of robot available in the research area, but we are going to take this robot manipulator, and the justification is as follows. So if you take any IoT automation systems, so these are the most common components. Like if you take a vision sensor followed by robot manipulator, software and hardware interface, IoT gateway, cloud service, big data analytics, and they're solving solution methods, and after that cloud computing. So these are the basic things. Apart from this vision sensor and the robot manipulator, the rest of the things are most common to any of the IoT automation systems. Okay, so we will see one by one about these components and how it is selected. So this vision sensor. Okay, so integrating this vision sensor with robot manipulator is very much essential. Before that, we have to select what type of vision sensor we have to take. We have to consider for the application. So there are much more applications with respect to the vision systems, starting from vision guided robotics, object detection, distance measurement. And then part localization and identification, edge measurements and edge detections are the most common applications of vision systems, which may include image processing if it is needed. So, for example, if you are taking that smart profile sensors and all, it will recognize the particular part and it will take the dimensional data from the images. And using that focal length and all the image data, we can convert from pixel measurements to matrix measurements. So like that, so these are some of the vision sensors available. So it's about the application, what we are going to implement. So apart from that, we can select with respect to the computation time and all. So these are some of the factors which can decide the vision system and its selections. And the next thing is about robot manipulators. I already discussed about some of the types of robot manipulators, and here it is classified based on the work volume. I mean, what is the working range it can move in X, Y, and Z axis, as well as the orientations, as well as the second is about motion characteristics. So there are planar, spherical, and spatial. We are discussing about more spatial characteristics of robot manipulator, and third one is about by based on the kinematic structure. So there are three types basically: open chain, closed chain, and hybrid. So this is the figure shows the open chain, closed chain, and hybrid manipulators. And next is about the selection of robot manipulator. So there are so this is based on we selected based on the work volume. So what is the work volume? It is the um, extent in x, y, and z axis, so that the TCP means the tool center point of the robot or the end effector can approach within the space. So that is basically the work volume. So using that as criteria, so we selected one of the robot as ABB IRB 120. So these are some of the robots available in serial manipulators. And next is about big data. So whatever the data we are generating in our local station, we are going to pump into the cloud, and there it is going to get solved. So in that area, the amount of data available for solving is very, very huge. So we need some specific methods to solve the data types. So there are if you take classification, there are a lot of classification is there: binary classification, multi-class classifications are there. So and here talking about this clustering big data, this k-means clustering is used in very various fields like image processing. For image processing and all, if we have multicolors in an image, then that can be easily classified based on colors using this k-mean clustering. And after that, we have that DVSE in clustering algorithm, then parallel clustering. And apart from this clustering methods, we have classification. So nowadays, deep learning and machine learning techniques are very much concentrating about the classification networks. If we take some pre-trained networks like AlexNet, GoogleNet, and SqueezeNet and all, they are more efficient with the transfer learning techniques, which are pre-trained networks available in the internet. So we can adopt those learnings into our problem. So we did the work on that, and these naive-based decision trees are some of the algorithms we are solving in machine learning. So these are some of the few methods for dealing with big data analytics. And so basically, this is the case study. We are going to look into it. So here, how the digital reconstruction is performed with an IoT-based devices and cloud computing. So our aim is to digitally reconstruct a 3D model using photogrammetry technique, and that would be happen automatically in the cloud. So that is the objective aim of the study here. So we selected a manipulator, serial manipulator first, and the object which is going to place inside the work volume is it's an off-shelf object. So we choose the very minimum industrial robot manipulator called ABB IRB 120. There is a model, basically small robot available in the market. And then the robot controller, which is a cabinet consists of each content and controller, from which we can give the inputs to the manipulator with the each content as well as the associated software called Robot Studio. And one more thing is that it has an RJ45 connection, that is the LAN connection. Using that LAN connection, we can if it is enabled with the internet, we can control the robot over internet. So we can control this robot by internet. There is a teleoperated robot, we can convert it. And then after acquiring images, so what the robot is going to do is it is connected with the camera mounted. So it will acquire images of the model which is kept in front of the robot. It will acquire images in different orientation and positions, so that these images are going to pre-process in the third stage called image pre-processing. And in the local system, then it will be pumped into the IoT gateway after pre-processing. And this IoT gateway will basically give some protection, firewall, and this kind of thing, and it will pump it to the cloud surface. So there we have the place to data store and process. And after this big data analytics shows that it can monitor the movement of the robot as well as the amount of data which we have received in the cloud, and this is the thing we can it can happen in the cloud. In the big data analytics part, it will do. So here our methodology will be applied for doing computation in the cloud itself. So we don't need more sophisticated GPU graphics processing units in our local desktop. So it all will be processed in the cloud. So that is the beauty here. And then, so model generation results that the reconstruction of 3D models is the process called model generation here. And if the model has any defects or defect holes, lack of features, then it will be iterated. Iterated in the sense which image has less correspondence or less feature points. That image and its relevant data. The relevant data resembles the position of the image taken. So that will be feedback into the cloud, and it will be pumped to the IoT gateway again, and it should be provided to the computer in the local station. So it will ask the robot to take an image at particular position. So that is the iteration happening here, and if iteration will continue till the model will generate a good quality of reconstructed one. So that is the aim to do iteration. So after, if the model is generated in good quality, then the same is to be downloaded to the local bit. So this is the overview of the automated IoT based automated 3D digital reconstruction. So we will see step by step of this case. So first, digital reconstruction. So there are a lot of techniques to do digital reconstruction using scanners and photos and all. So we are going to take this photogrammetry as a tool. So n number of photos are taken in different position and orientation of the object around, and these images are fed into our algorithm, which we can take or extract the feature points of the object present in the 2D images. And these feature points are nothing but the correspondence of images. So basically, minimum 2 images are needed to check the correspondence. So we are taking n number of images. The figure A shows the object, and the blue color rectangles are the camera with normal vectors, camera positions with the normal vectors. So like that, we are generating multiple images, and we are generating cloud points. Cloud points is nothing but the XYZ origins, vertices of the XYZ point, and using that we are generating some mesh models also. So these mesh models can be converted into suitable format for 3D printing. So here, this is whatever we are showing is some of the monuments which is available in the UNESCO heritage site called Mahabalipuram in Chennai. So we took some of the monuments and digitally reconstructed using this photogrammetry, and we found that there is a big deal with number of images and the defect codes. So if there is a large number of images, then probably we can get good quality of models. But our aim here is to minimize the number of images so that the positional error is comes into an account. So we develop a methodology so that in this question you can fix the camera so that you can reduce the number of images. So that's our optimum aim here. So by that way, we adapted a robot manipulator into this project. Okay. So this is the robot called AVB IRB 120, which has 6 degree of freedom and all has rotational axis here. So using this software called Robot Studio, we can able to program and simulate the environment, real-time environment into the software, and we can ensure that how stable your project is. I mean, the simulation is. Then after that, we have to assign frame. So using this frame assignment only, and we have to check whether the integration of vision system in the robot manipulator will work or not. So the integration part will start in the integration of vision system part will start here. So we are assigning that frame one by one here. Based on the DH parameter of the available robot called ARB 120, and using this DH parameter, we are assigning all this link parameters based on the kinematic analysis. And this is the model of the skeletal model of the ABB robot, walk-in robot analyzer. And so after this, we have to simulate or integrate the vision sensor into the robot. So here I took the vision sensor here as a camera, a DSLR camera. Nikon D5300 is the camera we used here. So, but the main thing is we have to align that image plane with respect to the TCP, tool center point. If it is perfectly aligned, then we can use this camera as a TCP. But the main thing is here, apart from this camera, if you use some what is that, welding gun or some other end effector, we can ensure that okay, this is the mechanical point. This is the point which can be acted as TCP. But here it's an optical instrument, so we have to ensure we have to align with the TCP where it should lie. So we took the image plane which is present in the camera, and the center of the optical axis is taken as an TCP here, and it is simulated in the Robot Studio software. After that, we found that in the table serial number 3 shows the TCP point. After the some set of procedure which is used to calculate the TCP, we found that these are the X, Y, and Z coordinates. So 539, 15, 574 in mm are the TCP coordinate points. We found that for this camera tool. And so this is the DH parameter. So here, based on this DH parameter, all the calculations were done, and we ensured that in the simulation, the integration part was done perfectly, so that if we change the orientation, not the position, then it is showing some good results over the orientations. So based on the, so this is the DH parameter. Based on this DH parameter, the work volume was ensured, and so this is the camera. Basically, it's a digital camera. So we used, and this figure shows that alignment of focal plane with respect to the tool center point. So with respect to the base coordinate system. So here our robot manipulator is there. It is positioned in front of the datum spread tool. So this datum tool is used to check the orientation analysis of the given vision sensor, that is the camera here. So we fix the position, and the orientation is changed continuously in all the 3 direction X, Y, Z. And we found that in all the orientations, the image captured by the image captured with the camera focused on the datum bed is compared with the image processing analysis, and we found that all the orientation are perfectly aligned. So here, and this is a methodology. Basically, we use it to acquire images. The simulation of image acquisition shows that the different camera positions initially plan to acquire images. So here, that yellow color object is our target object, which is used to acquire images. And the second and third figure shows the simulation of camera coordination in Robot Studio. So there, where we did the simulation for alignment of vision sensor. Then the last figure is about the experimental real-time experiment setup for calibration of camera 2 in the robot manipulator. And here, this is the experiment setup. So here we have 2 different experiment setup. So one is inside the work volume, and the next figure is outside the work volume. If the work object is large, it's a medium size work object, then we can do this kind of out of the work volume analysis. So using this, we did some good results. We generated some good models. And these are some of the models we have used. Basically, it's a heritage rated one. So we took some pottery and idols, and the same is compared with the 3D scanners. And we got some good results because 3D scanners has camera installed with the laser, but the camera is somewhat not enough to get some realistic 3D models. So that's why we are using this photogrammetry and extracting the feature points with some reliant, more reliable algorithms. and we are getting some good results based on the cloud computing photogrammetry analysis. And this is the summary. So in the summary, we can came to know that the validation and analysis of model generation is happening in cloud, and the iteration based analysis shows that if you have any defects in the models, it can be developed or reframed so that you will get the good model back, or you can download that. That is the thing. And then the reprogrammable system. So if we have anything to capture the image in some different location, so with respect to that location, the robot will be programmed again. Then it will pump this program in the cloud, and it will pump to the local station, so that it will be the images, corresponding image will be taken to the cloud again to do the same computation. And the main challenge is sensor alignment with the tool center point. If we are using these kind of cameras, DSLR cameras, they are easy to understand, but the thing is to align perfectly with the tool center point is difficult. So more effort should be needed to put the alignment. After if it is aligned, then it will be a reliable one. After that, you can do this kind of things. But whatever I shown in the slides as a selection of vision sensors, they are industrial based sensor, so that which you can mount with the plug and play system. So it is only 4 screws. You can align perfectly with the thing. Then it is very compact. If you see some smart vision sensors and industrial cameras, then it will be very reliable, and you can mount with a very easy manner. So that is the beauty of the industrial based sensors and smart vision sensors. And next one is data packet loss. So we are pumping the data into the cloud. So if any lag or delay in the data packets which we are sending to the cloud, it may result some defects. It may influence the results. So the reliable data should pump into the internet. So that is the main challenges we faced in this case study. And this is some of the video I want to show, which means, so what is the application of vision-based robots employed or used in the industries. So this is basically Amazon warehouse, first video, and second one is sorting different kinds of items in the basket. So that is the task assigned to these robots. So there are some challenges available in the internet. That's Amazon robot challenge. So it will use vision assisted robots for the challenges. So industries like Amazon, Alibaba, Flipkart, they are using these kind of warehouse and sorting techniques, robot assisted sorting techniques. So this is unavailable nowadays. So this is my presentation. I will stop here.
Okay, participants, if you have any question, you can ask.
Sir, Deep Patel is here. He will take the third part.
Yeah. Yes. Deep Patel is our new scholar working in the core IoT area.
Sure.
He is integrating various CNC machines, image processing system, and robotic devices. So with the IoT gateway, and planning to take data to the cloud and take back the data again for analysis and control, etc. Now I really request Deep Patel to share the content, and maybe till 2:55. Until 2:55 you can present it, and after that I think 10 minutes for for the test, right? Online test.
Sure.
So that is then 5 o'clock, 3:05. Then 5 minutes we can spare for discussion. Okay. Please go ahead.
Thank you, sir, for the introduction. I'll switch to the slide. First, I'll just like to check, is my audio there? Like, can you hear me?
Yes, your audio is clear.
Okay, and is the slides there? Okay,
Yes.
Presentation is also visible, right?
Yeah, it is also visible.
Okay, yeah, thanks. Thanks, Rajkumar, for introducing the robotics and vision and challenges on that. I'll add on to what Rajkumar has mentioned, and I'll focus on basically I'll basically try to converge whatever we have discussed so far. So what I'll start with very basic, like what the Internet of Thing is, what's the fundamental why it is, and then I'll move to like why in a manufacturing system which is already heavily invested and there is already a lot of technological improvement, why IoT is coming into the picture. Then I'll explain how it is done, like how the industry nowadays do that, and then I'll give the practical insight on what are the challenges the design and development of such system will have, and even on the security perspective. And finally, I'll just discuss some few points on like what is the next step after this. Okay, so yeah. So what exactly is Internet of Things? The easiest way to understand is that anything which is connected to internet is Internet of Things. Like as simple as that. It's in the name basically. So like if a toaster is connected to internet, then that's Internet of Thing. If your smartphone is connected to the internet, then it's an Internet of Thing. So by the definition, that's that. Now, how do you make sense of it? Like, okay, so way we can break down its essence, the Internet of Thing, is in the following way. Internet of Thing has three elements. First, senses and
Some audio issue.
actuators.
Patel, there is some audio issue.
Second is a means to. My audio is not visible. Yeah. Okay. What was my last point? You were able to hear?
Actually, your voice is interrupting.
Okay. So you weren't able to hear anything? Should I start again?
No. You can continue. Now your voice is clear.
Okay. Right. Okay. Yeah. Right. Okay, I'll just start with the Internet of Things again. So basically, Internet of Things has three elements. There is sensors and actuators, there's connectivity part, and there's people and process. Sensors and actuators are well known, like I won't go into details. I'll just describe a bit more on the connectivity part. What's that element? What's that factor? And then I'll brief on like how the people and process comes into the picture. So the connectivity part is basically how any device or any device or any cyber physical system is connected to an internet protocol. That's the very foundation. If it's a dial-up or it's a Ethernet cable or it's through a channel of Wi-Fi, Bluetooth, and there are many emerging channels like Zigbee, NFC, RF. Those are the different channels through which you can transmit protocols like Telnet, TCP/IP. So these protocols, when travel through this channel, are able to interconnect with. It's basically like the internet. Internet is basically connection of devices with each other and ability to transmit information freely from one point to another. So that's basic part of like what the connectivity is. And why is the connectivity important? That's important because the sensors and actuator, you get the sensors and actuator, but what do you do with that data? You have to transmit those data to someone to analyze it, comprehend it, and make insights out of it. So connectivity that's why important. So now, okay, you have the sensors, you have the actuators like the robotic arm and the vision camera. Now, what do you do with that after transmitting the information through, let's say, Wi-Fi? It's basically used for an application. Like you want to build a customer relationship, then let's say a best example will be a Tesla car, right? Tesla car has a feature where, like, contradicting to the legacy car makers, you can easily update the firmware of the car. So once the deal is there, once the car has been dispatched, you can still improve the firmware, and like as newer and newer updates can come, so that the product will also improve. Like just with a push of a button, like the cars will be new, basically, kind of thing. So similar to that, there are many applications in the industrial aspect as well. Like once you add sensors to the logistical cars, and like once you add to the manufacturing processes and start to feed this information to online database in the cloud, then this combination and collection of data helps us generate useful insights, which will improve the product and process productivity, which in turn helps people to have a better experience with the product. So that's how the Internet of Things come to the picture. So now, how does the Internet of Things can be implemented in a existing manufacturing setup? Like, let's say for this example, there's a globe manufacturing plant here. There are different devices and systems connected. Like there's a core robot which picks and plays the globe, and there's a vision system which analyzes the globe if there are any defects on the globe. Then everything is connected to a supply chain. So if once the product is ready, the third-party vendor will know, okay, now the product might be ready, so I have to ship the car so that to collect the package. So those kind of thing will come into the picture when you start connecting devices to the internet. And one of the best benefit of this is basically you have tons of data, but then you are able to easily identify any production flaws, then any like within a single let's say a laptop screen, you can know the whole how the plant is progressing and where the problem is happening just by looking at the sensors data. And like you can easily call up to a maintenance person, like this is the data, you schedule it on the same platform for the changes. So it's merging in a single platform so that all the processes are smooth, basically. You don't have to go to a multiple paperwork round to get the task done, basically. So what's actually inside the IoT enabled smart manufacturing work cell or anything? Okay, so we have field device. This field device has will transmit data in form of analog or digital, or it can be in a CAN bus communication protocol, Modbus, or other industrial standards like OPC, UA. This is the communication protocol. You have the data. Now, what do you do? Like you have various forms of different devices has its own way of sharing data. Now, what IoT gateway does is it is a merging point where all these types of protocol can be converged in a single place, and all the data can be captured, processed, like all the calibration value of the sensor and other structuring of the data can be done there. And it manages the scheduling of this data to a cloud platform. Now, what's a cloud platform basically? It's basically, okay, again, like it's fundamentally like a computer, but there are computer in a single room with tons of computer in a single place, just processing without a monitor. So it gives you the computing capability. Am I audible? Yeah, okay, thank you. So now you have this cloud platform. It was existing earlier. Now, in this cloud platform, it gives you infrastructure of processing, but it doesn't have a software architecture which can capture the sensor field images and process it. So now with the emerging research in IoT platforms, they have come into the picture, and using the cloud platform, they are able to have all the sensors data analyzed and and have different algorithms and different managing tools inbuilt in the platform, so that overview of a whole running system can be given. Like earlier there was SCADA was used, which was very limited to the local. Now if there's a multinational company running in different locations, like one in Japan, one in India, then the manufacturing process can simultaneously be viewed from one place to another, and it can be easily assessed. Like if any mitigation plan has to be set up, then decision making would be very fast. So that's under the hood. Now, from the schema information flow chart point of view, it's basically the same thing. It's just like you have the census data. It goes to a ADC. ADC is transmitted to a wireless or wired channel, which transmits the data to a IoT or cloud gateway, where the processing is done. And once the processing is completed, it pushes to the cloud. And cloud is where it now you can see, like there are so many devices, like hundreds of devices are there in the manufacturing setup. Now this devices will produce tons of data, like in TBs and GBs. So now you have so much data. Now the problem comes, okay, what do I do with this data? If you won't be able to process it in time, then it will just it's just a waste of memory basically. So I'll start with the problems now. What are the problems and challenges which IoT will bring? Not bring basically, which it currently has and we have to address, right? Like there was a survey which happened by Desktop Engineering magazine. They asked their readers basically, like, what do you think the emerging IoT design issues are? Like the top of it was the security, because now things are connected. There are more chances of hackers to have exploits. I'll take on the security part in the next few slides. Before that, I'll talk on the design part of it. So other point was design complexity. Now design complexity comes into the picture because now you can see, like, there are several disciplinaries coming into the picture. There's information technology, there's mechatronics, there's electronics, there's management, there's mechanical, there's biology. There are like different fields coming into the picture, and it also goes into the legislation part of it as well. So now you have this such wide field of things which have to be captured in a single system. Like you have to model it and like design it. So it increases the complexity of building the system alone. Like the time to make the system, like you have to find out whether it's worth investing in designing it or whether just keep doing what you're doing. So that's the complexity part of it, because there's no existing channel right now to make that part easy. Then the connectivity part of it, like we all know, there's always a network issue here and there. So how to make that reliable in worst cases, where like let's say a nuclear plant, you are running a nuclear plant, then you don't want the robotic arm to stop running in a critical, like in healthcare as well. Like you are running teleoperation from one surgery from one place to another. So you don't want the internet to break when the operation is happening, right? So connectivity has to be improved. There are flaws in that. I'll discuss on the flaws on those. And there's also the system integration flaw, that since it ties up to the complexity of it, because there are so many systems involved, it's difficult to integrate. I'll tell you why, particularly because there are many vendors around. Each has their own protocol. There's no standardization. So it's difficult to, like, if someone is talking in Japanese and other person is talking in Russian, so it's difficult to comprehend stuff. So that's what the communication protocol and standardization helps in. Like it tells people, okay, like if you want to process the data, then like let's say for example, speak in English so that everyone can understand. So those kind of standardization is required even in the IoT application part of it. And second most, the big data, which I was talking about earlier. Like the big data point is basically you have like 72 TB of data. Like this was one of the the other chart which you can see. It's It's a data captured from a mold making company for plastic mold. Basically, they have a sets of sensors attached to their vision camera to see the defect in the molding which has made, and the data which they produced for 1 year was about 72 TB, and that's fairly a lot to process basically. So this data has to be somehow processed and erased as quick as possible so that the load on the computers get down and more productive work can be done, right? So coming to like a very quick skim on what the challenges and the design and development challenges will be are the modeling part of it. As I mentioned earlier, there are a few mathematical models coming up to design a IoT based system for manufacturing, but the problem is none of them are so comprehensive like that all the touching technologies can be captured in a single model. So that's where the challenge is. Then there's a challenge of system integration and interportability. Like we all know, like the technology is improving rapidly. Now, once you set a manufacturing plant with a certain technology, it's very difficult to change. And IoT is something which is rapidly changing, and so it's difficult for the companies to commit to a single design basically. So the IoT should have a facility for interportability where a new system can be easily incorporated in an existing plant. Like, so that's another point. Then other challenges basically, as I mentioned, the technology standardization, and okay, then there is this semantic technologies, which is basically you have this bunch of data. Now, how to make sense of it? Like looking at it from like a holistic perspective of all the data which are moving around, getting the knowledge, getting the wisdom, getting the insights, and having that algorithm or like mechanism, or you might say software basically, which can comprehend this data now. So that's the semantic part of it. And as in all cases, power efficiency is crucial here because the devices are very small now, and it is battery operated. Most of the time it's battery operated. So you don't want to replace the battery again and again. That's the point of IoT was to reduce the maintenance of the equipment. And if you are to maintain the IoT device itself, then the point will be like not there basically, right? So that's why the power efficiency has to be improved. Even the number of elements which will be in the system has to be reduced basically. Now there are so many sensors that it's difficult to filter out, okay, what's needed, what's not needed. Like it's like your spam is filled with useless data basically, your email spam, right? One of a recent study on this design challenge indicated this very data part of it, where this IoT data has, like this recent study found that this data which they are getting needs a management process through which it is the data can be structured in a way it can be comprehended easily and easily transmitted around, analyzed and processed basically. Like let's say you have a machine, so you have all the parameters attributed to the machine, but you have same replica of that same machine. So the data has to be structured in a way that the essence of this machining operation can be easily comprehended and captured, right? And second is the obvious one, like the difficulty in software and hardware integration. Like you have a device. Now, how will it be connected to the software? Like, and like the points which I mentioned earlier, the same is repeating here, right? Now, from the security point of view, this is the major thing. I'll give you I'll start with an example. So, like in 2016, suddenly the Netflix and Amazon started, the servers were down basically, and this happened like these are the big websites which has a massive user traffic, and the reason why it got crashed was because there was a botnet named Mirai, which is basically what this bot did was basically whatever the
Patel, the time is now 2:55. Huh? Try to conclude.
Right. I'll try to conclude. No issues. Yeah. Thank you, sir. Thank you for input. So basically, this botnet basically, this Mirai bot, what it did was basically whatever the IoT device was connected in the internet, it basically hijacked it using like predefined hardware, because this IoT device doesn't have a good security inbuilt. Like those are very small devices, and there is a lot of cost cutting from the vendor's side. So these devices can be easily manipulated, basically. So this botnet went to the internet, found all the devices, and these devices, which was hijacked, now started attacking this website, Dine's web server, basically. It's a DNS server which caters to this websites, basically. And I'll explain the DOS attack in this slide. Yeah, DOS attack basically is imagine you have an ATM during demonetization. You had like a massive demand for ATM to give the money exchange part, right? You wanted to cash, and ATMs were not there. Similarly, DOS is basically requesting tons of data from a single device to give a service, but it's not able to do because like there are so many requests coming up. So that's what the DNS attack was there. And imagine your manufacturing part is happening and someone does that, then it will be difficult to manage the production, right? And other is like unauthorized access and information manipulation. Like someone just gets the access of your data and manipulates like the vibration data of the machine and makes it seems like the machine is working fine, but it's not. Like eventually the production will fail, right? There's this top listing of the security vulnerability, which you can like the slide will be shared. You can have a look at the website and know more about it. What's next? Basically, it's not all dark. Like there are new emerging technologies. Like for the standardization part, there's open standard enabling. There's one M2M. That's basically an organization which accumulates around 18 different standardization regulators in a single institution, and it tries to figure out how the IoT can be standardized. And there's this another IoT platform which I would recommend, which resolves all the security and development issues which I mentioned earlier. And like further research can be addressed to the challenges which was mentioned earlier. And with this, I'll request Rajkumar sir to conclude the session.
Okay, so now I think that before your session, you please share the link for the test. In the chat box.
Sure. I'll share the links.
We can request the participants to attend that test also.
Right. I'll share the link. No, I'll share it in the chat.
Yeah.
Right now. Control C, Control V. Right. So thank you for your time. Like if you have any doubt, I'll still keep presenting. So if you have any queries regarding the presentation, you can ask, and even sir like can conclude points.
Yeah, we have time. Yeah, we have time till 3:10.
3:10, right? Yeah.
Yes. Another 10 minutes. So parallelly, the participants are requested to complete the online test, and we will share the information to the organizer.
Right.
So that will be appropriate, and the feedback on the test and those things will come from the organizer. Probably will through the email ID we will share it. It's only a simple test, right? It's 10 questions are there, and kindly attend it. And read carefully and do it. So it is a simple test, and probably the other organizers also, I think they are conducting a series of tests.
Okay, dear participants, kindly fill the forms.
Yes. The test completed.
I hope the test has been completed by all of you. Completed means, would you please raise hands, sir? Would you please raise hands so that we will found right? We will find out how many yet to be.
So around 23 response are there.
They received.
Yes.
Okay, all the participants kindly fill that
Feedback of the current session, right? And
yeah.
the forms, I think you have to share the forms also, sir.
Pardon, sir?
The same old form, they got to old form. They go shared. You didn't share the form for session 23rd.
Yes, sir. After the completion of this session, I will share it.
Okay.
because otherwise they will confused. You have already forwarded.
Correct.
That's right.
Yeah. I think somebody asked to send feedback like for session 23 and
Right. Actually, sir, the when the session will be completed, after that we will
okay.
forward.
That will be correct.
So participants,
Every-
please fill the form which is forwarded by Mr. Deep Paresh Patel first. After that,
okay.
the
So after
second session.
so every session you are giving 10 minutes break.
Yes, sir.
Okay.
After each session, there is a 10-minute break.
Okay. Yeah, that is good. So, otherwise, they continuously sitting and.
Right, sir.
But I think morning session seems to be short and the afternoon session seems to be long. Is it so? Or
No.
when you say
In a day, sir, there are 5 sessions of 5 hours.
okay.
So, like you have delivered 2 sessions. Some of the experts have delivered only 1 session. So it varies with expert to expert. Most of the experts have delivered at least 2 sessions, means 2 hours.
Okay. So this is Atal sponsored, right? Atal ACT, right? ACT sponsored Atal, right? Atal.
Actually, sir, it is joint venture of RGBP and AICT.
Okay. Oh, it is a joint. So Sagar Institution Group, Sagar Group, what are the other institutions are there? This apart from this Institute of Science and Technology.
Actually, we have, sir, 3 institutions for engineering.
Oh.
The name is Sagar Institute of Science and Technology, Sagar Institute of Science and Technology Research, and Sagar Institute of Science and Technology Excellence. So we have 3 engineering colleges, then 1 MBA college, and 1 pharmacy college. So there are 5 colleges.
5 colleges.
Gee. Apart from that, this group actually this is a very old group and very reputed group of Bhopal. So they have 5 CBSE schools. The name is Sagar Public Schools.
Oh, 5 CBSE schools.
Yeah, 5 CBSE schools. Apart from that, they have industries also, and they have construction group also. So actually, this group is established in 1983. So it is a very reputed group and very old group, sir.
It is this institute is outskirts of Bhopal or within the core?
It is from Bhopal only, sir. All the business they have in Bhopal or nearby areas.
Okay. Within the city or outskirts? Outskirts of Bhopal or?
Means schools are in almost in city and colleges are almost in city, but the industry is far from the city, sir. Only the industry is situated around 40 to 50 kilometers from the.
How many all of this all completed? The test online test completed, sir. Did you receive the? Patel, did you receive the response? How many responses have been received?
I have received 34. So
okay.
We
still yeah, at least 90%, 92. Yeah, all of you should attend and okay. So some of you may take now the time is 3:10 and sincere thanks to all of you for attending the session. What is the total actual strength? Is it I don't know 60 or 55? Actual strength, actual participants.
Currently, sir, out of 51, around.
No, actual listed, actual strength.
Actual
participant. Yeah, actual strength.
It is near about 100, sir.
Oh, near about 100, but yeah, 50, around 50 are not available. Okay,
Yeah.
but yeah, that is a negative aspect.
All are working in different institutes and from various private institutions also and government institution also.
Yes,
so it is a very busy schedule for nowadays.
In fact, today it is a completely busy, and so I'm trying to find some time.
Even sir, we have a NAC accreditation today, and the team is arrived here, and the NAC accreditation is going on. Means the inspection is going on. Today also and then tomorrow also, sir. So these
Okay. So thank you for your invitation. Thank you for all the organizers and thank you so much for all participants. Okay, for attending our 2 sessions. And I think all of you are, I think all participants from throughout the India. I think from south to north and east to west. I think that it is a mix of participants. So thank you all. And please carry the information. And if anything is need to be discussed, please write us an email, and we'll continue our discussion. And please also visit our institute website for other updated programs and great other information. Okay, so thank you so much. Okay, anything is, I think now the time is 3:12. I think better you please disperse for the break, right? And then, okay, so now it is left to Nitin Kumar sir. Yes.
Okay, sir. Thank you very much for your precious time, sir, and for your session, sir. That was really wonderful session. And thanks to Mr. Rajkumar also and Mr. E. Paresh Patel also for your presentation. That was very nice presentation. And definitely, sir, in future also we will connect with you.
Okay. Yeah. Thank you so much. You are welcome.
Thank you, sir. Have a nice day.
Yeah. See you, sir. Bye.
Thank you, sir. I'll disperse.